Happy Monday, everyone. Welcome back to another Planetarium live stream. My name is Patrick Hess, Planetarium Specialist at Union Station. This is Phoebe, my cockatoo. And welcome back. Welcome back to another live stream. If you're a returning watcher, you may know that the last 2 weeks have been not live. They were pre-recorded because I was on vacation. So I hope you enjoyed those streams. They were pretty fun. I did a stream about... let's see, I did minor planets and dwarf planets. And then last week I had a pretty fun live stream all about celestial navigation. And if you haven't watched that yet, I won't spoil the surprise, but I put it together while I was away. So the location may be kind of funny. But check that out, both of those live streams and all of our past live streams. You can find them on our YouTube channel. Just search for Arvin Gottlieb Planetarium. And you can find us there. All of our pre-recorded streams we've covered, or all of our recorded live streams, we've covered a ton of topics over the past 8 months. All from all the planets in our solar system to a bunch of really fun and creative astronomy topics, looking at the science of movies and TV shows, as well as some of your favorite other fictional universes like Harry Potter. Yeah, they've been a lot of fun. So we're going to keep doing them. I've got a fun slate of live streams. The rest of the year should be live streams. So be sure to mark your calendars every Monday night at 6 p.m. Don't forget as well, Union Station and the Planetarium are open to the public. If you feel comfortable joining us, we are, of course, following every safety protocol as laid out by the mayor of Kansas City. So if you do want to come see one of our live star tours presented by myself or our other great educators, I'd encourage you to do that. You can buy tickets in advance online. Just remember that by the mandates made by the mayor of Kansas City, we are requiring masks for all guests. And of course, we are cleaning and sanitizing the seats. Just another reminder, this is a live stream. So if you want to say hello or ask a question in the comment section, be sure to do that because I'll be seeing those comments and answering them as they come in live. In fact, we're already getting one from Amy saying aloha from Blue Springs, Missouri. Thanks for watching, Amy. So if you want to shout out or if you have a question during the stream, be sure to throw that in the comment section and I will answer it there. Yeah, Phoebe agrees. We're going to see how long she lasts before trying to eat my computer. All right, so today's topic, because of the holiday this week, we are going to be doing a live stream. We're going to be doing a Thanksgiving live stream, and specifically, I'm going to be talking about why we should be thankful to space. Why should we be thankful for space exploration, for groups like NASA or NOAA, the National Oceanic and Atmospheric Administration? Why do we go to space? So hopefully we'll answer that question and we'll give you a better understanding of what is great about space and why we... All right, so as you can tell, this is live, and my bird just flew away and I think just crashed into a window. Oh, there we go. Here she is. All right, so... we've been doing these for 8 months, but they always will continue to surprise. I'm going to go ahead and send her back to her cage. All right. Ooh, boy. And we're back. All right. Sherry's chiming in, saying happy Thanksgiving. Thanks for watching, Sherry. Hope you enjoyed the stream today. And so like I said, we are going to be talking about, we're going to do a Thanksgiving stream about why we're thankful for NASA. Before we started, though, I did want to begin by talking about, covering a couple news stories that popped up over the past few weeks. Since we had a bunch of weeks of pre-recorded live streams, I did want to kind of go back over some space news that popped up. And Phoebe's very, very upset that she's not a part of the live stream right now. So we're going to see how things go. Let's bear with me, folks. We just came back from our vacation, so we're still getting used to things. In fact, give me one moment. Okay. All right. Whew, sometimes you need a vacation from your vacation, right? Okay, Jessica just chimed in asking what bird Phoebe is. Phoebe is a gala, or a rose-breasted cockatoo. They're native to Australia. All right, so like I said, like I've been trying to say, we are going to talk about some news stories that popped up before we get going to our main topic. This is pretty exciting. Tomorrow, China will be launching a mission to the moon. For the first time in 40 years, we are planning on going back to the moon, and specifically going back to the moon to take some samples back home. So this mission is going to be hopefully collecting 4 pounds of surface material from the moon and bringing it back to the Earth. So that'll launch tomorrow tomorrow afternoon. That'll be 3:25 Eastern, so it should be about 2:25 Central. So we'll be, let's see. Oh, actually, wait, hey, I might have read this wrong. Looks like it actually already launched. All right. Way to go, Patrick. Way to do your research here. Let's see. If it already launched, we should hopefully find out about that. Let's see. So yeah, I saw early Tuesday, and that would be in China. With the time zone change, it looks like it has already launched. Oh, and yep, I just pulled the wrong news story, so that's embarrassing. So China, let's amend that. We'll edit this in post. China has successfully launched its rocket to the moon. There's a video of it. All right, we're getting back in the swing of things, folks. It's going to be great. Thanks for bearing with me. So now China has successfully launched that rocket, and it looks like all systems were go for that launch. So it should get there in the next few days. And not sure how long it'll take to collect those samples, but we'll definitely keep you posted with all the accurate updates from that. All right, let's check our next news story. Make sure I can show you here. So this happened while I was away, and if you follow the Planetarium on Facebook, which if you don't, be sure to like and subscribe to the Arvin Gottlieb Planetarium for all of your space updates. But if you've been following along, you probably saw that the Crew 1 mission launched about a week ago, and that was the first official mission of NASA astronauts aboard the private company SpaceX's rocket. And they had just recently docked with the International Space Station. So those astronauts are up there. The mission was successful. And this marks the official beginning of the American Space Agency contracting with a private company to take our own astronauts to space, which is exciting because for the past decade before that, we were hitching rides with the Russian spacecraft, which were good spaceships too. But, you know, it's nice to be able to take our own astronauts to space for a change. Let's check out what else is going on. All right. So this is great. This was a study that was just published in the by Cornell, it looks like. And this basically, these scientists were studying geologic activity on Mars. And what they found is that Mars is a lot more geologically active, or has been recently, much more recently than we thought. We used to think that it had been millions of years since significant geologic activity has happened on Mars, but basically they were doing studies of Mars, and they found that in studying one of the craters, by their estimations and measurement, not estimations, but by their scientific study of it, they basically determined that it's likely that that crater was formed by a volcano that erupted very recently, anywhere from 50 to 200,000 years ago, which has a lot of implications because right now we are unsure about how geologically active Mars is. We don't know if its core is dead or if it has a molten core similar to the Earth. And that is really important to understand because if we were ever to go to Mars, we need to know how geologically active Mars is because the molten core of the Earth is what creates our magnetic field, which protects the Earth from solar radiation. If we send astronauts to Mars, we want to make sure they're protected from radiation. So it's important to understand that about Mars. Let's move right along. Here's another interesting little story that popped up. It looks like there's a private company that is working on plans to turn scrapped rocket parts that are orbiting in space into space stations. So there's a problem with space junk, space debris. Basically, a lot of the rockets we send to space will have stages of them that are jettisoned when they go to space. So, you have a rocket booster that takes the rocket to space, but then detaches, and that booster is still floating around in space while the rest of the rocket may come home or go to its eventual destination. So there's a lot of space debris, and the European Space Agency actually published its annual space report this year, and they highlighted that abandoned rocket bodies were one of the biggest threats to spacecraft. So basically, this private company, which is called NanoRacks, had just announced that they are working on plans to potentially turn spent rocket parts that are just floating around in space junk basically, to convert them to space stations. So take the space junk and sort of repurpose it and rebuild it, add components to make it a livable space habitat. So it could be pretty exciting. Obviously, the debris will still be in space, but if we attach thrusters to it, we can control it, we can monitor their locations, and it'll be a little safer. So this kind of project is years or even decades out from happening, but it's cool that some people are thinking about, how we can clean up space, because there's a lot of space junk up there. Let Amy move right along. In kind of bummer news, we've been kind of tracking this story, but the Arecibo Observatory had a couple of their wires actually have structural failure basically, and damage part of the telescope. Now this radio telescope is in Puerto Rico, and it's been looking for extraterrestrial life, basically. That's its main mission. And essentially they've just announced that the damage that was made to this telescope is so severe that they're planning on just demolishing the observatory. Unfortunately, it's unsalvageable. So they will have to tear it down. Hopefully there will be future projects following along in this mission. There you can see some of the damage. And this was just an accident. It just happened, structural failure that they couldn't predict. So it's unfortunate that this observatory's mission is ending, but there will be others, I'm sure, to pick up where it left off. All right, and a little happier news, sort of maybe bittersweet news, I guess, silver lining news. NASA released some data that they've basically been doing some research models about how the crisis this year has been affecting the climate, and in a positive way. So basically, they've discovered that essentially the global nitrogen dioxide concentration, which is one of the thought to be one of the materials that contributes to pollution and climate change, has dropped and been reduced by nearly 20% since February. So here's actually some, this is right above Wuhan, China. This is pollution levels, the density of that nitrogen dioxide that I mentioned. And as you can see, compared to last year, it's significantly lower. And actually has maintained that and not actually sort of jumped back, in this case, after the Chinese New Year. So a lot of bad things happening this year and a lot of negatives to what's going on in the world, but kind of a bit of, a little bit of silver lining there. And then just one last fun story that popped up. I saw a meteorite crashed through the roof of a man's house in Indonesia that was worth basically about 100, so this is $248 million dollars, I think, in the local currency, but in our currency, it's worth about $1.85 million, so in American dollars. And this meteorite just crashed through this man's roof, and he eventually sold it to some dealers, not for that amount of money, but obviously it's worth that amount of money, but whether or not somebody would buy that is a different story. But this rock is probably as old as the solar system, so kind of crazy that those things can happen to anybody, and hopefully that person made a lot of money from that freak accident. All right, so those are the news stories, and I'm going to jump back in. A lot of people are commenting. Some people commenting about the bird. If you missed that, my parrot was here for the beginning of the stream and had a bit of a freak out. Amy says, my cockatiel's name was Larry Bird. He stayed at Grandma Marilyn's house while we were on vacation and flew away from her. Oh no, that's sad. Well, I hope that Larry Bird is happy wherever Larry Bird is. Jennifer says hello from KCK. Hi, Jennifer. Hi from KC Mo. Emily says hi from Hope, Kansas. Thanks for tuning in, Emily. Gina says hello from Lee Summit. Thanks for watching, Gina. Amy says, space junk, upcycle or repurpose. Exactly, yeah. We can turn our ideas of recycling from down on Earth back up into space. Trace says, hello from Warrensburg. Love the stream. Thanks for watching. So glad you're joining us. A couple questions popping up already. So Carl is asking about that Chinese mission. Is it a manned mission or a crewed mission, as we like to say in the year 2020? It is not. This is a robotic probe that is planning on grabbing some material from the surface of the moon and bringing it back. I'm not sure if it's going to land on the moon or if it's just going to sort of drop down and grab something and pop back up, kind of like the OSIRIS-REx mission that grabbed material from an asteroid that was pretty recent. But it is an uncrewed mission, Carl. Jennifer asks, saw something streak through the sky to the south on Friday night, even through the cloud cover. Any news on what that was? Ooh, interesting. Through the cloud cover, I'm not too sure, but there has been a meteor shower that's been going on, the Leonid meteor shower, and it goes through about a month, and we're still sort of in it, although it peaked a few weeks ago, or about a week ago. So it could have been a meteorite. The meteor shower should have produced, I think, about 1 per minute. Not 1 per minute, rather. Let's see, what was the rate? Sorry, 15 per hour, so about 1 every 4 minutes. Yes, I think I did my math right there. It's still technically going on, but again, it did peak about a week ago. But there's a good chance if it was bright enough, you might have seen it through the cloud cover, depending on how thick that cloud cover was. If it wasn't a meteorite from the Leonid meteor shower, though, Jennifer, then I'm not exactly sure what it could have been. Maybe an alien. Amy says, did you go anywhere on vacation? And I won't spoil that, but if you do want to know a little bit about where I might have gone on vacation, be sure to watch last week's live stream, which was presented live, although I did produce it while on vacation, pre-recorded. But I did film it on the spot where I was on vacation, so maybe you'll get a hint about that. If you check out that recording, you can find that on our Facebook page or the Planetarium YouTube channel. Eric asks, will that debris eventually enter the Earth's atmosphere as the orbits decay? That's a great question, Eric. And most likely not, especially a lot of these boosters that are part of the rocket to get it to space. They often are on extremely wide trajectories. And some of these rocket boosters, these space debris, are much further away than a lot of typical satellites orbit. And that's one of the big reasons why there's so much space debris up there, and why it's going to be difficult to get it back, because a lot of these debris orbit in very eccentric orbits, very oval-shaped orbits where they get close to the Earth and then really far away. But a lot of them are on those trajectories that don't ever really enter the Earth's atmosphere. Occasionally, if rocket scientists are really careful, they can plan a rocket launch so that debris does re-enter the Earth's atmosphere. But a lot of the debris is from really before where we used to care about that. And then, current innovations in rocket technology, like SpaceX's Falcon 9 rocket, circumvents the need for space debris by taking the booster rocket back down to Earth, and they land it on a barge on the ocean. So that is a great solution to the space debris problem, although it doesn't change all the debris that's up there right now. But a good question, Eric. All right, so wow, we're almost 20 minutes in, and we haven't even started the topic yet. Thanks for your patience, everyone, if anybody's still watching. Hopefully you are. But let's talk about our stream topic today, and that is all about NASA. Why? Really the question I want to start with is, why spend money up in space, right? Why do we spend money up there when a lot of people say we have so many problems down here? That's a common thing. People think, well, why are we even going to space? What's the point? All of our problems are down here on Earth, and we got to figure those out before we can even go to space. Well, there are a couple answers to that. First of all, human beings have this amazing superpower that they're able to care about more than one thing at a time. And the fact of the matter is if we tried to solve every problem we had on Earth, we would never go to space. Just like how if Europeans tried to solve every problem they had over there, they never would have explored the New World or, come to America. So we can work on solving our problems down here and work on going to space. And as we'll learn during our stream today, a lot of the problems we have here on Earth can be solved by going to space. So there's another misconception about space exploration, and I'm going to specifically dive into NASA just because that's relevant to a lot of our viewers, and that is where a lot of the data is. But a lot of people think that we spend a lot of money in space. In fact, there have been a number of studies done. In 2007, there was a study done on the public perception of NASA. And during that 2007 study, they found that the majority of the public, on average, the public, when asked to estimate how much money they thought the United States spent on space exploration, again, this was in 2007, the average estimation was 24% of the federal budget. So the average American thought that we spent 24% of NASA, the entire U.S. budget on NASA. This was just in 2007. That is for sure not true. So here is a breakdown of every year, and this I think goes to 2017, but you can still see the trend here of the percentage of the federal budget dedicated to space exploration, specifically to NASA. Now, of course, during the space race, we spent a lot of money on space exploration, but even at its peak, it wasn't even at 5% of the national budget. And then as you can see, as the space race died down, it's been below 1%, and for the past decade plus, almost 2 decades, it has been less than 0.5%. So we spend less than 0.5% of the federal budget on NASA. And that amounts to, this year's budget was approved by Congress for $22.6 billion, which sounds like a lot, but we'll break that all down. In fact, let's break it down now. So where does that money go? Let's just kind of dive into what we spend for NASA specifically. So here's a breakdown of NASA's budget, and as you can see, a lot of it goes to science and exploration, with some other things like technology, space operations, staffing, basically, and safety. A lot of money is spent there as well. To break down the science portion, though, about half of that is for planetary science, so deep space probes going to distant planets or elsewhere. And then 1/4 of that is Earth science, so satellites looking back on the Earth, studying the Earth. And another 1/4 of that science portion there is on astrophysics research, so studying stars and expanding our understanding of physics and the origins of the universe. The exploration budget there, most of that these days is going towards development of the Orion capsule and the Space Launch System, which is NASA's system that they are planning on using to send astronauts to Mars. And as NASA transitions away from using their own rockets to send humans or probes to space using private companies like SpaceX, right now they're working on that next big step of the next system that will take humans beyond the moon and hopefully to Mars. There was another study done by Business Insider in 2018, so a little more recently, and the estimations were a little better then. But the estimations at that time were... one more thing, actually, just about the budget. I just wanted to point out that the way this works, I'm not going to get too into, how this all works. You'll have to check out Schoolhouse Rock to learn more about this. But basically, the White House and the president specifically will request a budget, and then Congress will actually enact that budget. And actually, over the past 4 years, Congress has approved generally a higher budget than the White House has requested. So that's great. And in fact, the budget of NASA has been increasing by, a couple of percentages, so not a lot, but it has increased a little bit over the past 4 years. So again, there was that 2018 Business Insider study, and at that time the estimations were a little bit closer, but still most people estimated that about 6.5% of the national budget was spent on NASA, which is completely incorrect. Of course, the 2018 budget, similar to the 2020 budget, is about 0.5% compared to the Apollo era budget. And interestingly, this study also asked people how much money they thought we should spend in space, and just based on this survey, they found that they preferred a higher budget than they had estimated, 7.5%. Now, that 7.5% of the national budget would be about $300 billion. So if NASA was given the amount of money that the people of this study wanted NASA to be given, we could build 2 international space stations every year, or we could send a crewed mission to Mars every year, according to some government estimates. So interestingly, that this study, less than 2/5 of the respondents guessed within 1% of the correct portion. So a lot of people still don't understand that we do not spend a lot of money going to space. We spend a lot more money on a lot of other things. Here's another interesting part of this study. So based on their perception, a lot of people thought that NASA should get a raise or have this the same, and less than 1/4 of the people surveyed thought that NASA deserved less money. And then, based on their preferences, the raise to the NASA's budget, as I said, would be astronomical, for lack of a better word. And then here's just a breakdown of the budget as compared to everything else the United States spends money on. And you can see NASA in red there. Tiny portion of all the other things that the United States is spending money on. Carl, by the way, is asking, where does the Space Force fit in on that budget? And as far as I know, the Space Force is in the military or Defense Department, since that is considered a branch of the United States Armed Services. But that's a great question, and I do wonder. So it looks like the Space Force for next year has been its proposed budget is $15 billion just for the Space Force. But again, that does fall into the Defense Department budget. So that is not a NASA budget. But that's a good question. Casey says, hello from Gladstone. Thanks for watching, Casey. All right. So, where were we? All right. So, all this to say that we really don't spend a lot of money on space. Comparing to international spending, the whole world doesn't spend that much money on space. The United States represents 1/3 of the worldwide $60 billion budget spent on space agencies. Second place is China, which only spends half as much as the United States on space. And then the third place is the European Space Agency, which spends about 1/3 of the US budget, about $7 billion. So people just aren't spending money on space. Stephanie quoted in the comments, the U.S. Space Force was established December 20th as an independent service under the Department of the Air Force. So it's a part of the Air Force, which is, again, part of the service department. But thanks, Stephanie. Thanks for doing a little research for me. So, first of all, that misconception, we don't spend a lot of money on space. But the second part of that is, of the money we do spend on space, why are we going to space? What's the point? I mean, there's exploration, sure. If it weren't for exploring the world back in, a few centuries ago, we wouldn't have come to the United States. Different people argue whether or not that was good. But in general, a lot of us are here because of that. But why go to space? And are there discoveries made in space or inventions or innovations that help us here on Earth? Well, the answer, of course, is yes, and that's what we're going to talk about during the bulk of our stream here today. Why are we thankful for space? What can we say thank you to NASA and just to space exploration for? What can we be thankful for when it comes to going to space? So first, let's talk about some innovations. Now, in microgravity, there's a lot of research that can only be done there. So I'm going to talk a little bit about different discoveries and innovations made aboard the International Space Station, which is our microgravity research environment. We've spent $100 billion collectively as a world, all the different world space agencies to build this space station, and it's been up there for 20 years. Well, what's it been doing besides, astronauts just throwing M&Ms at each other and doing cool flips in space? Well, it's been doing a lot of really important research. For example, in microgravity research aboard the International Space Station, they have been doing a lot of really important medical research. So they have been studying, in microgravity, studying cells, organics, protein clusters without the influence of gravity or even the forces of walls of containers can actually help researchers a lot get a clear understanding of the properties, behaviors, and responses of medical treatments. And just as some specific examples, what we're seeing right here, I believe, is some cancer research being done. And there is a lot of cancer research that can only be done aboard the International Space Station. Right now, specifically, they're studying the growth of endothelial cells on board the space station. I'm not a biologist. Hopefully I pronounced that right. But endothelial cells help supply blood in the body, and tumors need that blood to form, of course. And in the space station, that was just a little video showing you some of that research. In the space station, these cells grow much better than they do back here on Earth, and this can help test new cancer treatments a lot more rapidly than we can on Earth. There's also Alzheimer's research. Without the interference of Earth's gravity, researchers can study protein clusters that can cause neurodegenerative diseases. There's Parkinson's research, asthma, heart disease, all going on aboard the International Space Station. Some other interesting types of research. Here is a video of the discovery of steadily burning cool flames, which are pretty interesting. I won't get too deep into the science there, but essentially this discovery and continual research on it could lead to more efficient and less polluting vehicles. Basically, a combustion that produces different materials that aren't as polluting as what our current combustion systems do. So Amy is commenting, we need to manage our planet. We do, of course, need to continue to solve all the problems we have on Earth. But as we'll see, and as I'll hopefully show you, a lot of the problems we have on Earth can be solved in space. So we've talked about medical research, and we've talked about, this discovery, cool burning flames, could definitely help with pollution and potentially climate change. There are water purification systems that have been developed aboard the International Space Station that help us on Earth. It brings clean water to third world countries, or it can bring clean water to communities that have less access to it. There's also drug development taking place aboard the International Space Station. Specifically, growing crystals aboard the space station allows for slower growth and higher quality crystals, and this is important when it comes to developing certain drugs. And just as one specific example, this particular development has huge implications in the treatment of Duchenne muscular dystrophy. I hope I pronounced that right, but this is a genetic disorder that affects 1 in 3,600 young boys, and developing a drug that could treat this disorder may only happen aboard the International Space Station, so really important. There's also methods to combat muscle atrophy and bone loss that are being developed aboard the space station, because astronauts, when they're in space, don't have a gravity to keep their muscles from atrophying, since they're not using them as much. So research on astronauts' muscles and, of course, exercising those muscles aboard the space station is helpful and could help people back on Earth, especially medical patients that are bedridden and, their muscles are deteriorating from that as well. And then, of course, there's just monitoring our planet from a unique perspective. There are other agencies besides NASA that need space, like the National Oceanic and Atmospheric Administration, as well as the National Weather Service. They all use about a dozen satellites that were made possible thanks to space exploration. And of course, weather is important for predicting or for helping everything on Earth. I don't need to really tell you that meteorologists are really helpful for a lot of things, but also tracking pollution and understanding climate change there, of course. Yes, so Eric mentioned, or said, to not forget the space pin. And I'm glad you brought that up, because the next section I'm going to talk about inventions. Inventions made by NASA or in partnership with NASA for space that have helped us back on Earth. And I'm going to start with some misconceptions. So there are actually a couple inventions, a couple urban legends that have gone around that actually are not tied to space. And I want to talk about the space pin, so I'm glad you brought that up, Eric. So let's start with that. So the space pin was an urban legend that's been circulating for decades. Basically, the story goes that NASA spent hundreds of millions of dollars to develop a space pin, a pin that's able to write in space without the influence of gravity. All the while, the Soviet Union just use pencils to solve that problem. Makes a great story, and it definitely erodes our faith in the government, which, like, we need another thing, right? But that is not true. NASA also used pencils during the space race, and they actually use felt-tipped pens that work fine in microgravity as well. So they did not develop a space pin. In fact, they were on the way to do that, but when the story broke out, they canceled those plans because of public perception. Let's see, a couple other misconceptions. Tang, for example, another fun urban legend, but Tang was actually invented by General Foods. It was used in early space missions, though, so that may be why the urban legend came out of that. And then Velcro, surprisingly, was not invented for space exploration. It was invented by the Swiss back in the 1940s. And of course, it's been very helpful for space exploration, but it was not invented for space exploration. And then also Teflon. Some people claim that Teflon was invented by NASA, but it was actually invented by DuPont in 1941. Of course, NASA does use it for things like heat shields, spacesuits, and cargo hold liners. So glad you brought that up, Eric. Oh, and Eric also says the USDA uses satellites to monitor crops and other land characteristics. Yeah, thanks for bringing that up. That's a really awesome point as well. Looking at agriculture is a huge thing that impacts us on Earth, a lot more than a lot of people realize, and using satellites to monitor those things from that unique perspective is incredibly important. So thanks for bringing that up, Eric. That's a really, really good point. But let's talk about some inventions that were created by NASA or for space exploration. One example is LASIK. LASIK eye surgery a lot of people have to prevent the need of glasses or remove the need of glasses. This was developed in the 1980s for autonomous space vehicle docking, if you can believe it, that laser technology. Right now, most spaceships use LiDAR, but back then LASIK was used. And then, of course, its development was taken for eye surgery. Infrared ear thermometers were developed for space exploration, as well as cochlear implants. Invisible braces were actually developed in partnership with NASA, the material used for invisible braces, I should say. They was basically invented to be used as a material for infrared antennae and heat-seeking missile trackers. But for whatever reason, scientists figured out that material was also useful for invisible braces. Thermoelectric aircraft anti-icing systems, another thing developed for space exploration. Highway safety systems, also a lot of some research on runways that NASA did has led to increased highway safety and better road construction, better tire construction. This is interesting. So NASA partnered with Goodyear to develop a fibrous material 5 times stronger than steel that was used for parachute shrouds for the Viking Mars landers back in the 70s. And then Goodyear used that development to increase the quality of their car tires. Pretty cool. Landmine removal, it can actually be done using surplus rocket fuel, apparently. Firefighting equipment, a lot of firefighters these days actually use a lightweight breathing system that was created for spacesuits originally. And they also use inductorless electronic circuit technology, which has led to the development of lower cost and more rugged shortwave two-way radios, which apparently are really useful for firefighters. Shock absorbers to protect buildings from earthquakes that were invented to absorb sonic waves from rocket launches. And of course, that helps protect buildings from earthquakes, like I said. Water purification systems, I mentioned. Solar cells, better GPS systems, which I talked about last week during our celestial navigation stream. Software for structural analysis. So a lot of really important inventions. And I wanted to show this off. This is very cool. And we'll put a link in the comments for you to explore yourself. But NASA has put together this really neat website that basically traces space back to you. It's homeandcity.nasa.gov. Again, we'll put a link in the comments for you. But this is a really fun visualization, great for kids as well, to explore what things in space have come back down to Earth to help us. So there are 2 different sections. There's your home and the city. We'll just start with the home here. We won't go through a lot of it, but I'll just kind of showcase. We'll go to the kitchen first. So this is a really cool interactive thing that you can look around and look at all these different things in your house. And for example, let's, we already talked about, there you go, water purification. NASA engineers worked with private companies to create better systems for clean, drinkable water. Let's look at this, a precision coffee maker. Looks like a NASA intern, or a former NASA intern, created a advanced coffee maker that you may be able to use. A freeze-dry technology. This was invented through NASA research to help make the food taken to space a lot lighter, which makes traveling to space a lot cheaper. The more stuff you take to space, the heavier it is, the more expensive it is. Of course, space ice cream is maybe the most famous example of that, but freeze-dry technology is used elsewhere as well. Let's look here. Growing plants in space has evolved as well, so there are a lot of commercial companies that have indoor gardens you can use. So basically, you can just hover over this and look there you go, self-driving farming equipment using GPS technology. Definitely comes back to us here on Earth. Now let's go back and check out a different thing. Let's go to the bedroom, see what we've got here. I know one of them right here. Temper foam. So if anybody has a really cool memory foam mattress, this was invented during NASA research project. So this memory foam definitely helps us back on Earth to have a better sleep. LED light bulbs were developed for NASA, and of course today LEDs are ubiquitous, and that low power, low heat light technology is helping us to lower our energy needs. Liquid metals used for sports equipment. Phase change materials, clothing that are, let's see, so more comfortable clothing basically. Fabrics that don't trap as much heat or sweat. So flexible aerogel, this is really cool. You can buy, so aerogel I've talked about a bunch of times on our streams. This was a material developed by NASA to capture comet particles to study, but now this material can be found in a lot of jackets. It's an extremely lightweight but highly insulative material. My winter coat is actually has an aerogel layer as well, but that's very cool. Improved footwear, better shoe technology. So anyway, there's a lot of amazing things. I'm going to let you explore this a little bit more on your own, but as you can see, all the different rooms of your house. And then you can also visit the city, and this visualization has a lot of things I've already talked about. We can go to the airport here, and I've talked a little bit about that already. You can see the airplane here. Anti-icing systems I've mentioned already. Collision avoidance systems. So very useful, and nobody wants to run into something while you're flying. Voltage controllers used for escalators. There you go. So a lot of things that you may not even think about, all innovations thanks to space exploration. If we weren't going to space, if we weren't exploring space, a lot of these innovations would not have come back to us here on Earth. And there are a lot of things that a lot of people don't realize are thanks to us exploring space. So you can see a lot of even some sport, even our recreation, and advanced heart rate monitors developed for spacesuits and astronauts. So panoramic photography. So if you've ever watched a football game, a lot of that technology may have been developed thanks to NASA innovation. So a lot of really awesome things. I'll let you explore this more at home. Again, that's homeandcity.nasa.gov. Hopefully we'll put a link there in the comment section. Hopefully is just gives you hopefully this shows you that there are countless examples of specific examples and tangible examples of things that space brings us, things that we can be thankful to space for, and all these innovations are things that a lot of people don't realize are just because we are exploring space. Now, I did want to end the stream today to talk a little bit more intangibly. So those are all the things that we can point to, the specific examples, but there are some intangible things that I did want to mention a little bit. Things that you can't really hold or see, but hopefully things that you can understand are benefits to exploring space. And one of those benefits, one of those intangible benefits, is just expanding our knowledge, expanding humankind's knowledge of space and science, understanding the origins of our universe and of our solar system. Just like any other exploration of science, whether it's physics or biology or math or any of those things that people research, understanding more about space expands our knowledge of science. And as with many areas of science, of course, answering a question about science often causes new questions, but that just enhances our understanding of the world. There's also understanding details about our solar system, about our planet, specifically about the Earth. So when we study other planets like Venus and Mars, learning about how those two planets used to be very similar to the Earth and are definitely no longer similar to the Earth, learning about them can maybe help us to understand potential futures for our planet. Mars, we know, was covered in water 1 billion years ago. Why isn't it anymore? And the Earth is covered in water right now. We don't want the Earth to stop being covered in water sometime in the future. So understanding what happened to Mars can hopefully inform our decisions about how humans impact the Earth. And I do want to mention, if you want to learn more about how both Mars and Venus were similar to the Earth, I did live streams both about Mars and Venus earlier this year, so you can check that out. Elizabeth says, very cool. Thanks for mentioning that, Elizabeth. I hope you are enjoying this stream, Elizabeth, and I'm glad you are appreciating all the cool things that space exploration has brought us. Eric asked, does NASA get patents on any of that technology? That's a good question. Often those technology innovations are partners with other companies, so perhaps they get patents as well. But I'm not exactly sure how that works with government organizations. I assume there are patents involved with that. But I'd have to do more research, so I'm not going to answer that question at risk of not knowing the right answer for it. But that's a good question nonetheless, Eric. So the last thing I wanted to mention about exploring space, and I think one of the greatest benefits is the global cultural and the global perspective that we get when we go to space. First of all, international cooperation is a huge thing that has come out of space exploration. For example, this photo was taken on July 17th, 1975. And this was, in this photo, you can see American astronaut Thomas Stafford and Russian cosmonaut Alexei Leonov. And this picture was very historic. A lot of people say that this picture is essentially one of the first and maybe biggest symbolic photos that show the beginning of the thawing of the Cold War here in 1975. Basically, this was the result of the Apollo-Soyuz test project, where NASA and the Soviet Space Agency worked on a project where they would dock 2 different spacecraft in space, and they did it successfully, and those astronauts were shaking hands, and this is in the middle of the Cold War. But since then, for the past 4.5 decades, space cooperation has happened around the world, and a lot of people say this is really the first thing that started that. And of course, this didn't end the Cold War, but it definitely, hopefully, a lot of people say it was kind of a symbolic act that was led us down that path. Then, of course, there's the International Space Station, which is I've talked at length. You can, of course, learn more about the ISS if you check out a live stream we did a month ago on October 19th. I built an International Space Station out of Legos, and we talked about all the different parts and history of the International Space Station. But as we know, the International Space Station was developed over 20 years by over a dozen different space agencies around the world, and it stands as a beacon of international cooperation. We live in divided times, but we can look at the International Space Station as a great example of what humans can accomplish when we all work together. Amy says, I need to sign off playing the ukulele. I have played the ukulele on occasion during my live streams. If you check out last week's stream, you may have caught that as well. Maybe I won't sign off with the ukulele this week just because I don't really have that prepared, but perhaps I'll bring it back in future live streams, Amy. But I will sign off with one last thought, and that is something called the overview effect. So we're going to talk a little bit about this. The overview effect is something that a lot of astronauts claim that they've experienced when they go to space and they look back at the Earth and they see the whole planet all together at once. This is a quote from Edgar Mitchell from the Apollo 14 mission. And he said, after seeing the Earth from this distance, you develop an instant global consciousness, a people orientation, and intense dissatisfaction with the state of the world, and a compulsion to do something about it. From out there on the moon, international politics looks so petty. You want to grab a politician by the scruff of the neck and drag him a quarter of a million miles out and say, look at that, you blank. I may have censored the end of that quote, but you can probably imagine what you might want to say to somebody when you see the whole world as just a small island of blue out there in the inky blackness of space, and thinking about the whole world as 7 billion people just floating on this island of nothingness. A lot of people say that it gave them, a lot of people who've gone to space say that it's given them a perspective unlike any other. And the last thing I wanted to leave you with, and I'm just going to say that we are going to end after this. So if you have any comments or questions, be sure to put those in now. Because this will be the last thing I will end with, and we'll just check into the comments now. In fact, Carl says, watching from Sumner, Missouri. Thanks for tuning in, Carl. And Elizabeth says that their dad has a piece of the Apollo heat shield. Always intrigued about space and all the things we have done. So fascinating. Thanks. Thank you for this live. Well, thank you, Elizabeth. That's really awesome. If you have a picture of that, that'd be so cool. If you want to share that, we'll put it on the Planetarium Facebook page if you'd like to send that in. But that is awesome, and I'm glad you're enjoying this live, Elizabeth. And so the last thing, again, this idea of a global perspective, this photo is the pale blue dot, and that is this little dot right there. This photo was taken by the Voyager 1 space probe on February 14th, 1990, from a vantage point of 3.7 billion miles away. That's further than the planet Neptune. And this photo was organized and really suggested that NASA take this photo by Carl Sagan, who is a famous astrophysicist and a science communicator, a lot of us know, and he's written a lot of really poetic things about space. And after this photo was taken, this picture of the Earth as just a tiny dot, a little blue pixel against the inky blackness of space, the furthest photo of the Earth ever taken. He commented on this in a book he published in 1994, and this is what I want to leave you with. And I probably have given you this quote before, but it's one of my favorites, so it's worth repeating again. So I'm just going to quote what Carl Sagan said in 1994 in response to this photo taken of the Earth from 3.7 billion miles away. And here's what he said. We'll go like this. So Carl Sagan said, "Look at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity and all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world we know so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. And that was Carl Sagan again, commenting on this photo of our pale blue dot, that tiny speck of light suspended in a sunbeam billions of miles away. So thank you all for tuning in for our live stream today. Hopefully I've given you a perspective on our explorations of space, and hopefully you come away from this stream with a little bit of an appreciation for why we go to space, as well as a better understanding of how much money we actually do spend on space exploration. And I hope you enjoy that, and I hope you will think a little bit more about NASA. And if you explore that website, you can maybe be thankful for NASA, and you can find something else in your home that you can thank NASA for. But I hope you all have a wonderful week. I hope you enjoyed this stream. I hope you have a fantastic Thanksgiving if you're celebrating that, and I hope you have a safe one as well. And Eric says, when will NASA get us the spice? And to that I say, fear is the mind killer. Casey is commenting and says, very appropriate quote for the times. Thanks, Patrick and Union Station. Well, thank you, Casey. Thanks for watching. Thanks for all of our returning watchers and first-time watchers. As a reminder, you can watch all of our previous live streams on our YouTube channel. Just search for Arvin Gottlieb Planetarium. You can find them all there. That's a great way to support Union Station. You can also support us by tuning in next week, next Monday, for our next live stream. Our topic next week will be, we'll be doing a lunar live stream. We have not actually talked about the moon yet. We've done a ton of live streams about other places in our solar system, other moons in our solar systems, but there is actually going to be a lunar eclipse coming up at the end of this month, and it's going to be partially visible here in North America. So we'll talk a little bit more about that. And we'll be taking a deep dive into our moon, talking about our nearest neighbor, celestial neighbor. So if you want to learn more about the moon and learn more about lunar eclipses, and specifically the one will be happening, that will be happening next Monday, in fact, then be sure to tune in at 6 p.m. That's a great way to support us. Of course, you can support Union Station and the Planetarium and myself by coming to see one of our live star tours or any of our other planetarium shows. We are also doing our holiday favorite, Laser Holiday Magic. So if you want to check out some holiday classics in celebration of the coming month, you can check that out with our laser spectacular system there. And we're also, we brought one of our shows back all about the Apollo program, Capcom Go. It's a history show about the history of the Apollo program. Great for all ages, but should be a lot of fun. And again, buying tickets, of course, to the Planetarium is a great way to tangibly support us. And of course, watching our live streams supports us as well. So thanks to everyone who tuned in. Thanks for everyone who liked and commented. And happy Thanksgiving to all of our watchers. Carl and Casey saying happy Thanksgiving as well to all of our space nerds. But I have been your Planetarium Specialist, Patrick Hess. Hope you enjoyed this stream, and I will see you next week. Happy Thanksgiving, y'all.